A 55.9 gram metal pellet at 75.8 grams degrees Celsius is dropped into 193 grams of water at 27.1 degrees Celsius. Their final temperature is 50.3. What is the heat capacity of the metal? So we know that the water is going to gain heat because it was at the lower temperature and the metal's going to lose it. That means that the Q of the water is equal to the negative Q of the metal. So the first thing you need to do is list out all your information, just like straight from the problem. Okay, mass, C, delta T. Delta T is always final minus initial. Okay, the final temperature was 50, the initial was 27.1, so it's a positive number for the water. That makes sense. The water's going to gain heat. For the metal, we're solving for C. Delta T here is going to be negative because its final temperature is lower than its initial temperature. Remember, it's final minus initial, so one of them is always going to be negative. Well, not always, but usually. Now, since Q is equal to MC delta T, we can plug in MC delta T for here and MC delta T for here. So now we're just plugging in our data. 193 times 4.184 times 23.2 is equal to negative, don't forget that negative sign, 55.9 times C times 25.5. We do a little bit of arithmetic. Now notice negative times a negative gives me a positive. We do our algebra. We come up with a heat capacity of 13.1 joules per gram degrees Celsius.